Welcome, geometry students, to the homework help video, page 193, numbers 7, 8, 14, 15, and 20 through 30. Let's go ahead and get started with the homework help video, and let's start off with numbers 7 and 8, okay? Number 7, first of all, if you knew that AB, right here, is congruent to BC, right here, what other piece of information would you need to prove that this triangle here, I'm going to highlight it in green for you, triangle AEB is congruent to triangle CEB. Okay? What other piece of information would you need to know? Well, there's more than one answer to this, okay? Let me go ahead and say this. We already know that this side here is congruent to this side here, and we know they share the same side. So if you wanted to prove that these two triangles were congruent, we could say this angle here is congruent to this angle here. That would be angle ABE is congruent to angle CBE. Angle ABE, this angle here, is congruent to angle CBE. That would give you side, angle, side, or we could also state that we need to know that AE is congruent to EC, and if we went that route, this segment here congruent to this segment here, then we would use the side, side, side reason, okay? So either one of these two answers here would be sufficient, okay? All right, moving on to number 8. If you knew that triangle AEB, I'll highlight that in red for you, was congruent to triangle CEB, and you also knew that triangle AEF I'll highlight that in green for you, was congruent to triangle CEF, then could you prove that this big triangle right here is congruent to this big triangle here? Okay, so let's take a look at that and see if we can, okay? So students, let's take a look at this. Notice that we already stated if we know that the red triangle is congruent to the red triangle over here, then we do know that this side here is congruent to this side here, correct? And notice this, students, notice that if the green triangle is congruent to the green triangle, which it is, then we know this segment here is congruent to this segment here. So erasing all of this stuff for a second here and putting those marks back on, look, we know this segment here is congruent to this segment here, and we know this segment here is congruent to this segment here. So really, all that we need to know is that this segment here, BF, is congruent to BF, and we know that's true. So we can definitely state that this big triangle over here is congruent to this big triangle over here because of side, side, side. I mean, look, we have one slash here, one slash here, two here, two here, and the two big triangles share this common side. So yes, it is possible, and the way you would use that would be side, 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 okay? All right, moving on to number 14. Now, you are surveying a lake as shown below. You want to prove that triangle COD is congruent to triangle BOA, okay? So that once you prove that, you can then state that AB, this side here, is congruent to this side over here, CD, okay? That's your goal. So how can you prove that these two triangles are congruent? By looking at what we have here. Well, it's pretty simple. Look, they've already noted that this length here is congruent to this length here, and they've already stated that this length here is congruent to this length here. So really all that we're missing is this. Vertical angles are congruent. So how can we prove that these two angles are congruent? Well, we know that vertical angles are congruent, so it's really quite simple. We have side angle side of this triangle here congruent to side angle side of this triangle over here. So the way that we would state that these two triangles are congruent would be side angle side. Okay? All right, moving on to number 15. Now you are surveying a lake, and as shown below, you want to determine the length of AB. Okay, you want to find this length. However, here's the problem. You can't measure any segments that cross the water. So which measurement will allow you to find the length of AB? Well, that's pretty obvious, okay? We know that this length here theoretically would be the same as this length here, okay? So here's what we have to answer. How do we know that this length over here, CD, is the same length as AB? Well, here's what I'm thinking, guys. Look, first of all, notice this. Notice how this angle here is congruent to this angle here. Now, that's important because look what you have. You have a line here and a line here. Now watch this, being cut or intersected by a transversal. And look at this. This angle here with one dot and this angle here with one dot. Those are alternate interior angles. And we learned a long time ago that when two lines are cut by a transversal in such a way that the alternate interior angles are congruent, then we know those two lines are parallel. So right off the bat, I can state that these two lines here are parallel. Okay? Now that I've stated that, that means this. Now watch this carefully, students. That means this angle right here. Let's see here. Hold on one second. Let me look this over here. That means this angle right here with one mark is congruent to this angle here because we have two parallel lines right here cut by a transversal right here. And when two parallel lines are cut by a transversal, their alternate interior angles are congruent. Okay? So I do know this angle here is congruent to this angle here. Okay, I also know that this side here is congruent to this side here. So think about this for a second, students. Watch this. See this triangle right here? Okay. And see this triangle, let's see, DCB and ACB. See this triangle right here in red? Do they not share a common side? Sure they do, right here. So I have side, angle, side, congruent to, in the green triangle, side, angle, side. So, which measurement will allow you to find the measurement of AB? CD would. CD would. Now, do we know that? Well, we know this red triangle here, triangle ACB, is congruent to this green triangle here, which is triangle DBC, and we know that by side, angle, side. So once we state those two triangles are congruent, then we can definitely state that AB is congruent to, hold on one second, sorry about that, AB is congruent to CD, okay? I hope that made sense. It's a pretty tough one, okay? I hope that made sense. Okay, moving on to number 20. I don't even need the diagram for this proof. I don't need it at all. This is so funny. Look at this. Look at your given right here. They want us to prove this, okay? Statements, reasons. Watch how easy this is. Okay, here's your given right here. Okay? Triangle PVQ is congruent to triangle UWT. It's right here. There's your given, right? Now they want us to prove that VQ is congruent to TW. What's right here? VQ. What's right here? TW. So we're done. We can definitely state that VQ is congruent to TW by CPCTC. Remember, once we state that two triangles are congruent, then we can state that any of its parts, any of the corresponding parts, are congruent to any of the corresponding parts over here. Okay? All right, moving on to number 21. Actually, let's jump on to 22, okay? 22, and then come back to 21, okay? Now, 21, same thing. Look at this. PS congruent to RU, right there. So we're done, guys. Look, let's prove that PS is congruent to RU, okay? Number one, we have our given. SQP is congruent to triangle RTU. That's your given. And now look, here's PS right here, and here's RU right here. So we can definitely state that PS is congruent to RU by CPCTC, okay? Because once we state that triangles are congruent, then we can definitely state that any of their parts are congruent, okay? All right, let's go back now to 21. This is the more difficult one, okay? All right, here we go. Now we're dealing with angle TRW. So TRW. So probably this triangle here, I think, okay? And we're dealing with angle USW. So USW right here, okay? So I'm going to draw those two triangles separately, okay? So here's this triangle. This triangle RTW. And here's the other triangle going this way. And this triangle ST. And this should not be a W here. Sorry about that. This should be a U. Triangle RTU. This should be a U. And triangle STU. STU. Okay, now look, we're trying to prove that this angle here, TRW, is congruent to this angle here, USW. Now, do we have any statements in our given dealing with triangle RTU? Yes, right here. And triangle STU. Yes, right here. See that? Right here. So right here we have something in our given that deals with these two triangles. Okay, so let's see if that helps us, okay? So I would state, number one, my given triangle RUT is congruent to triangle STU. And of course, that's your given. Now, look this over here, guys, carefully. Angle TRW, which is this angle right here, TRW, is really just angle what? R. And here's angle R. And then angle USW is really just angle what? S. And here's the angle S. So we're done. I mean, TRW is angle R, and angle USW is really angle S. So I can state now that angle TRW is congruent to angle USW by CPCTC. Okay, so let's review this one again. As soon as I realized I was trying to prove two angles congruent, I came over here and found those angles. And I saw one of the angles was here, and I saw one of the angles was here. So I immediately assumed I would probably need to use these triangles here. And I was right. So I copied those triangles down here, and then I looked at what I had. And I had RTU. So I looked up here in my given for a triangle RTU or RUT or whatever, and I found it here. And then I looked for triangle STU, and I found that right here, and I realized these two triangles here are what? Congruent. It's given to you right here, and you're given. So once I knew that, I could just line up the appropriate angles and make sure they lined up. And then if they did, I could state the angles were congruent by CP/CTC. Remember, whenever two triangles are congruent, you can state that their corresponding parts are congruent, okay? All right, moving on to number 23. All right. If you'll look in your book, this picture here is a picture of the times that Air Force, Navy, and Army have played each other, okay? Now, question number 23. From the data given, just looking at the data right here, is it possible that Army beat Air Force 16 times? Let's see. Does Army have 16 wins? Yes. And does Air Force have 16 losses? Yes. So that part checks very good, okay? Now, let's see. And then would it be possible for the Army to have 24 losses? Yes, because the Air Force has 26 wins. So yes, it is definitely possible that Army beat Air Force 16 times, okay? Because Army has 16 wins and Air Force has 16 losses, okay? So it's definitely possible. All right, now moving on. Who did Navy tie? Well, let's look for some ties here, okay? It looks like Navy has a tie, and it looks like Army has a tie. So, who did Navy tie? Well, they tied the Army team. Okay? All right, number 25. How are the win ratios determined? If they were not given, could you use other given data to calculate the win ratios? Okay, students, now on looking on how to figure the win ratios, how they're determined, what you do is you realize here they played a total of 42 games and they won 26. So 26 over 42 would give you the win ratio, okay? 0.619, 26 divided by 42. Now over here, if you add up all of these games here, you will see they played a total of 41 and they won 19. So if you take 19 divided by 41, you will get the win ratio, okay? And then over here, if you'll notice, they played 41 games also, and so they won 16. So 16 divided by 41 will give you the win ratio, okay? All right, now it asks the question, could you use other given data to calculate the win ratios? I'm not quite sure what they mean by that question, except maybe they're saying, could you, I just don't know. I'm trying to figure out what they're asking their students. I'm not going to really worry about it. Could you use other information to I suppose you could. It would depend what the other given data was, okay? But I would say yes, you could. All right, number 26 here. How many times did Navy play Air Force? Now, if you'll look, there's 42 games here, 41 games here, and 41 games here, okay? How many times did Navy play Air Force? Well, you got to figure if there's 42 games here, and they played 21 times against the Navy, and they played 21 times against the Army, okay? So, how many times did Navy play the Air Force? 21 times. 21, okay? Okay, moving on. Now, number 27. Let W, L, and T be the total number of wins, losses, and ties for the three teams. Write an equation that relates these numbers. Okay, it's so easy. All of your wins plus all of your losses plus all of your ties would equal 124 because they put a total of 42 games here, they put a total of 41 games here, and they put a total of 41 games here. Okay, there we go. So if you add all of those up, you would get 124. So that's a pretty simple equation. Just take all the wins plus all the tie losses plus all the ties. It will equal 124 total games. Okay. All right, let's continue on. Okay, sorry for yawning. Let's see what we have here. If Rashad is not up, let's go ahead and change this right off the bat, students, if we can. All right, there we go. All right, now let's go ahead and take this top equation, this top sentence here, and let's change it so that we don't have the not, and we don't have the not. So we're going to write the contrapositive. Remember, we change, we negate the hypothesis, and we negate the conclusion, and we swap places. So we're going to negate it by getting rid of the negative. So that word's gone, and that word's gone. And then we write if he sprained his ankle, if Rashad sprained his ankle, then he's on crutches. Okay, so that takes care of this phrase right here. It's gone. Okay. So let's see what we have here. If Rashad sprains his ankle, then he's on crutches. If he's on crutches, then he can't play basketball. Okay, but if he plays basketball, his team will win. All right. So now be careful on number 28. You want to say yes right away, but the answer is not yes. The answer is not enough information given. Let me explain why. If Rashad is on crutches, did he sprain his ankle? Now look carefully. It says up here, if Rashad sprains his ankle, then we know he's on crutches, okay? But it does not say if he's on crutches, then we know he sprained his ankle. There's a big difference, okay? If he sprains his ankle, we know he'll be on crutches, and that's pretty normal. But if he's on crutches, he could have torn his knee. He could have messed up his calf muscle. He could have sprained his ankle. He could have broken a toe, okay? So Rashad is on crutches. Did he sprain his ankle? We don't know. Now look at this. Rashad sprained his ankle. Can he play basketball? Let's see. If he sprains his ankle, then he's on crutches. If he's on crutches, then he can't play basketball. So if he sprained his ankle, we know he's on crutches, and we know if he's on crutches, he can't play basketball. So can he play basketball? No, he cannot. Okay, now, can Rashad's team win if he sprains his ankle? We'll be careful. It says here, if Rashad plays, then his team will win. That doesn't mean, though, that if he doesn't play, they'll lose. They still might win, okay? So if Rashad plays basketball, then his team will win. Now, if the question, if number 30 said, Rashad played, did the team win? We say yes, because it says right here, if he plays, his team will win. But can Rashad's team win if he sprains his ankle? Or in other words, if he doesn't play? Well, we don't have enough information, because we know if he plays, they'll win, but nowhere does it say if he doesn't play, they won't win. Okay, so we don't know that for sure. They still might win without him, okay? So not enough information given. Okay? Students, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.